So I'm going to show you how to make a class hierarchy in Objective-C. So in a class hierarchy, you want all the rich people on top and all the poor people on bottom. And you want there to be a lot of poor people on bottom and very few rich people on top. So to make a class, you do the @ symbol, and then it's actually implementation. It's kind of different, or you do interface and implementation. It's different from C++ where you just use the word class, but so we'll do interface, and every object needs like a root object, right? So we're going to start with the lower class. Just call it lower. It's going to inherit from NS object. Then we do the @ and end. So this is like an Objective-C portion of the code as it parses it. I think that's how it works. So we have our lower class, and class in a class hierarchy is based on different things, like different factors, such as like wealth is like the biggest one, and maybe things like race, maybe gender too. So we can add those in. So wealth is the easiest one. So we'll do double because you want to do financial values for you want to do calculations on money with a double and not with a float 32 or a float, because it just won't be accurate enough. So double wealth, and then other factors you could have. Let's say int race, and int is usually a number, but we can actually implement different races too. We can do enum race. It's like a feature of C that we can use in Objective-C. So let's start with what races are there? We have like white people, and I think we have to start with 0. I think it's a comma. I think you have to comma deal with this. So we do white, black, and then you don't have to put the numbers anymore. Hispanic. It's a race, or actually, let's call it Latinx. Why not? Let's just do that. Let's just enforce that word. And also Asian. And I don't think we need a comma for the last one. But yeah, those are all the races. And we can let's just do that for now. So wealth and race are the biggest ones. Actually, yeah. Maybe we can do bool gender. Let's enforce the binary too. Bool gender. Actually, I got a better idea, because this bool is actually an int or something. So import standard bool type h. There we go. Enforcing the gender bool. There we go. Perfect. Now, these are different properties of someone within the class. So to be able to change those, to be able to edit those and stuff, you want to have a getter and a setter, which is like classic object-oriented. But it's kind of annoying to type that all out in the implementation, so you can just do property double wealth, and this makes the interface declaration automatically for you, so that you don't have to type that all out. You just type property, and it just works. And we do race, bool. Okay, perfect. Okay, cool. Now, this is the interface, and what we can do, because we want each class in the hierarchy to kind of inherit from the other. So let's say middle class. So let's do middle class. So now we have middle. Ooh, if I can spell. And then we don't need all this because we already implemented all that. So now it's going to inherit from the lower class. So all the benefits of being middle class is going to like be based off the effort that the lower class puts in. So, you know, just everything the lower class does is for middle class, and then the same for middle class for upper class. So basically, like, that's how a hierarchy works. I don't think we have to do the properties again either. We just have to have the interface. We can do upper, and then we'll get to the implementations. Upper, middle, that's right. God, I can't spell. Okay. Alright. So implementations. Usually I like to put the implementation like right under it, but there's only 3. It's not huge, so I can just do 3 implementations like this. So implementation lower. And there won't be much to put in here. Other than, oh, whoops, we didn't put those. Let's see, why is this not? Oh, that's right. Implementation. Ooh, yikes, I can't spell. There we go, implementation. Now, we only have the declarations for these properties, but we want to actually implement the getters and the setters. And that can be done automatically too, with synthesize. So you just synthesize wealth. I think they can be done in one, I'm not sure. I'm just going to put 3 of them, just in case. Okay, there we have that. And then I don't think we have to implement anything else for the other 2. Actually, be easier to do this. Implementation middle. And I think that's totally valid. Perfect. Perfect. Middle and upper. Okay. So these are all going to have the same properties. So if I make an upper, okay, let's try it. I will show you. So upper class is going to inherit from middle class, which inherits from lower class, which inherits from NS object. So that's all the good stuff. NS object has all the good stuff. We need to allocate and initialize our class members. So what we're going to do is we're going to make an upper, and it has to be a pointer to an upper object. So it's called up. Maybe I should explain what pointers are, but not today. That's a C topic, not an Objective-C topic. So we can we'll do upper, send a message. So this syntax here, this is sending a message. And this is sending a message directly to the class. So it's sending it to the class itself. We want to allocate a new upper object, right? And then we want to initialize it. So you send a message to the upper class itself to allocate it, and then it returns what it allocated. So it returns that address. And then to that, we send the init message to initialize it. And then we store that in up. That's what's happening here. So now that we have that, we need to set its different properties. So we can see. So let's do up, and you can use the syntax in Objective-C 2.0, I believe. You can use the dot, so we'll do up.wealth. And let's say this is upper class, so he needs billions of dollars. So up.wealth equals, we can do 1e plus 09. We can do, yeah, we can do that. Make it double. Okay. So 1e plus 09. That's like a billion or something, or 10 billion, I don't know. So he's very wealthy. And let's make him white. So we can also do up.race equals white. And then we can do, what was the other thing? Oh yeah, gender, right, okay, so we can enum that too. We can do male equals 0, female equals 1. And there we go. Up dot gender equals. Okay, cool. So we have all these properties. Now we want to maybe print them to the screen so we can see what they are. So we can implement a printing method on each class by putting it on the lower class. So I'll do. So this is how you do it. You put a. This is how you declare it. Declare a method. So you put a dash. This is and a dash, like the minus symbol or whatever. This is for a instance method, not a class method. So a class method you call on the class itself. An instance method you call an instance of the class. So this is an instance method because each one is going to have its own wealth, its own race, its own gender. So this would void because it doesn't return anything. The name of the method. So we'll just do print. Just call it print it, or I don't know, print properties. Yeah, that's fine. Print properties. We'll do that. It doesn't take any parameters. We won't go over parameters. We'll just make a method because that's simplest. And this is only the declaration, so you don't put the actual implementation in here. You put it down here. So this is lower, so we'll put it in lower. Implementation lower. And that is this. You do the same kind of syntax here. Properties. And this time you put curly brackets. And you write it. So now I could use nslog or I could use printf. I prefer printf. Unless I have to print out an actual Objective-C object. So I'll use printf. And printf, you just make the format string. So let's do wealth, which is double, so that's percent. Actually, let's put the dollar sign and the percent. And then a double is like a long float, so we do LF for long float. And we want to round it to the nearest 2 decimal points because you don't really need to see anything beyond that. Like that's as low as it goes to like a penny. So you can do 0.02 in front of LF. We'll do a new line. And then we can do we can do self.wealth, or we can just do wealth. I think that works. But if you want to be sure, you could do self. Actually, I want to try that. We'll try it. We'll see if we get an error or not. Self.wealth. Then we want to do the other ones too. So we want to do race. And then this can be... Oh, okay. That's right. You can't just print out the number. You need a switch statement. So let's do a switch. I'll show you how to do a switch. So wealth is easy because it's just a number. So we can do switch. Switch self.race. Okay. Now, each case of a switch statement kind of looks like this. So case white. That's what it looks like. And then colon. And then we're gonna do printf. So if the case is white, we're gonna print white. Race white. And then new line. And this is the string. Usually I don't like to print them like that, but this is totally fine. I like to do this, %s/n. And that works. I think that's better. In case you're using user input, you don't want the user input to be in here, but there's no user input here. So it doesn't really matter, but I always like to do this. And then each case in a switch statement falls through to the next unless you put a break. So if I were to do this and do the same thing here, what it's going to do, if I don't put a break statement here, it's going to go white and then black. And you don't want that. You can't be white and black at the same time. So I'm going to do break. Break. You could also put break over here if you want, if it doesn't make the code as long. It just looks nicer sometimes. Not all the time, though. And then, let's see, what else do we got? Oh, yeah. That's right. Okay, so we'll just copy and paste these. Perfect. Okay, cool. So now it can print out what race it is. That's perfect. And now the same thing goes for the gender. So we can do a ternary operator for that. That'd be a good idea. So we can do self gender, and then a question mark, and then I think how it goes is if it's true. Let's see. So, okay, so female would be black. Okay, so I think the true one comes first. We'll test it just to be sure. And then a colon. So this is the statement if it's false. So statement if true, statement if false. And then, okay, so this is going to check this. If it's true, it goes here. If it's false, it goes here. I think that's it. So now let's try it. So we have the up class right here, and then we gotta send a message to it. So we'll do send a message to up, and the message is print properties. Since Objective-C and C are kind of the same, like Objective-C is just layered on top of C, you still need to return C. So we can do that. And what we need, I was messing with some of this earlier, so we can do something. So I'll show you how to compile it to see if it works. So to compile it, I'm using GCC. So GCC main.m, or no, class.m is what I called it. So .m is the extension for Objective-C files. We do -o for output. Class is the name of the executable. And we want to link this with lib Objective-C, so -l, and then immediately after objc. And you don't have to put the library like right next to it like this. If it looks weird, you're like wondering like how does it know to separate these, because it sees the -l first, but that's really what it means with the space in between. So, and then we also want -l GNU step base, because it's a GNU step program because it uses Foundation, but I'm on Linux. You could probably make the same exact thing on a Mac if you have what is it called? I forgot what the program was called, like Xcode or something. So let's see if it compiles. Oh, it removed the G. I don't know how that happens, but it does. Okay. Expected specific qualifier list before end on 30. On 30. Implementation. Where was this from? Okay, so that one's from 75. Let's split this up just in case. Set it at 30. Oh, that's why. Or no, this. Yeah, okay. This is why. I think you need those. I'm not sure. I should just remove them entirely. Let's see. Okay, compiled. Perfect. Now we'll try it. Awesome. Awesome. We have a class hierarchy. Let's make another one. That's amazing. Okay. So now let's do a lower class. So send the message to lower, allocate it, initialize. And let's do lower.wealth. And let's give our lower classmen here. Let's give them like 1E plus 03. That's pretty lower class, I would say. That's like a salary or something. Lower.race. Make it black. Lower.gender. Let's do male again. And we can send the same message to our lower classmen here. Compile it again. And, oh, see, it just works. It just works. Object-oriented programming is great. Class hierarchies, they make everything work. They make everything work. It just works. So, what you can do now, this is a cool feature of Objective-C, is that it's dynamic. So you can have ID, and let's just say ID random, because it can be any random person. ID random. And we'll set it to equal to lower here. So ID is kind of like a generic class. It's a pointer, but it's not a pointer that's specific to one of these things. It can be anything. So instead of sending it to lower, I can send it to random. And random is equal to lower. It'll print the same thing. And there you have it. And you can also do the same exact thing with the methods. And I think that's a bit different. I think I can do... I think that's cell method equals... I think it's at selector, and then you type in the name of the method. So print. I think that's how it works. And we send that to our ID here, random. Let's see if that works. No method send. Oh. Well, perform selector. That's what it is. Perfect. It just works. It just works. Object-oriented programming. There it is. It's perfect. There you have it. Well, that's a great class hierarchy we just designed here. So, well, see you guys later.